Class diagrams are just one tool that can be used in the software development process. Whether or not to use a class diagram, or any other tool, will depend on the specific needs and goals of the project. What system type are class diagrams useful for? Class diagrams are useful for modeling the static structure of a system, particularly the relationships between different classes and objects within the system. They can be used to represent the structure of a system at any level of abstraction, from high-level overviews to detailed design specifications. Class diagrams are commonly used in object-oriented software development, where a system is designed as a set of interacting objects that collaborate to perform certain tasks. In this approach, each object represents a specific entity or concept within the system, and the relationships between objects reflect the interactions and dependencies between these entities or concepts. Class diagrams can be used to model the structure of many different types of systems, including business systems, information systems, and software systems. They are particularly useful for designing and documenting the structure of complex systems that are composed of many interconnected components. Overall, class diagrams are a useful tool for visualizing and documenting the structure of a system, and they can help to clarify the relationships between different classes and objects within the system. They can also be useful for communicating design ideas and concepts to stakeholders and for helping development teams to understand and implement a system. How analysts and product owners can learn about the structure of a system. As analysts and product owners, you can learn about the structure of a system by following these steps. Define the scope of the system, determine the boundaries of the system and what is included within the scope of the analysis. This will help to focus the analysis on the relevant components of the system. Gather information about the system, identify the sources of information about the system and gather data from these sources. This may include interviews with stakeholders, review of existing documentation, analysis of existing systems and processes, and observation of the system in action. Identify the components of the system, identify the key components or entities within the system and how they interact with each other. This may include processes, data, people, and technology. Document the structure of the system, use tools such as class diagrams, flowcharts, data flow diagrams, and process maps to document the structure of the system and the relationships between its components. Validate the accuracy of the documentation. Review the documentation with stakeholders and subject matter experts to ensure that it accurately reflects the structure of the system. Update the documentation as needed. Continuously update the documentation as the system evolves or as new information becomes available. By following these steps, you can gain a thorough understanding of the structure of a system and how it functions. This understanding can be used to identify problems or inefficiencies within the system, and to propose and evaluate potential solutions. Here is an example of a high-level class diagram for a simple online shopping system. In this example, the customer class represents a customer of the online store, and the order class represents an order placed by a customer. The customer class has three attributes: name, email, and address, and no methods. The order class has four attributes: customer, product, quantity, and price, and two methods: calculate total and place order. The calculate total method calculates the total cost of the order based on the quantity and price of the product, and the place order method places the order with the online store. This class diagram shows the relationships between the customer and order classes, with the order class being associated with a customer object and aggregating a product object. The diagram also shows that the order class has an inheritance relationship with the product class, indicating that the order class inherits the characteristics and behaviors of the product class. This is a high-level class diagram because it only shows the main classes and relationships within the system, without going into too much detail about the specific attributes and methods of each class. It provides a broad overview of the structure of the system and how the different classes and objects interact with each other. Here is an example of a more detailed class diagram for the same online shopping system. In this example, the customer class has three attributes: name, email, and address, and three methods: get name, get email, and get address. The order class has four attributes: customer, product, quantity, and price, and four methods: calculate total, place order, confirm order, and cancel order. The product class has 4 attributes: name, description, price, and quantity, and 4 methods: get name, get description, get price, and get quantity. This class diagram shows the relationships between the customer, order, and product classes in more detail than the previous example. It includes the specific attributes and methods of each class, as well as the inheritance relationship between the order class and the product class. This is a more detailed class diagram because it includes more information about the specific characteristics and behaviors of each class. It provides a more detailed view of the structure of the system and how the different classes and objects interact with each other. Next, what is the usefulness of class diagrams for writing technical stories? Class diagrams can be useful in writing technical stories by providing a visual representation of the structure and relationships between different classes and objects within a system. This can help to clarify the requirements and goals of a technical story and to ensure that all relevant stakeholders have a shared understanding of the intended functionality. Here are some ways in which class diagrams can help in writing technical stories. Visualizing the system. Class diagrams can provide a clear and concise visual representation of the structure and relationships within a system, which can help to understand the system and to identify potential issues or areas for improvement. Defining class attributes and methods. Class diagrams can specify the attributes and methods of each class, which can help to define the expected input and output of the system and to understand how different classes and objects will interact with each other. Identifying dependencies. Class diagrams can show the relationships between classes, such as inheritance, aggregation, and association, which can help to identify dependencies between different parts of the system and to understand how changes in one class may affect other classes. Communicating design ideas. Class diagrams can be used to communicate design ideas and concepts to stakeholders and development teams, which can help to ensure that everyone is on the same page and working towards the same goals. Overall, class diagrams can be a helpful tool in writing technical stories by providing a clear and concise representation of the structure and functionality of a system. They can help to define the requirements of a technical story, to identify potential issues or dependencies, and to communicate design ideas to stakeholders. What topic do you want covered next? Please comment below. Thank you.